Okay, this tutorial is going to continue the lesson on subnetting and why it's important to know binary, and I'm going to just keep rolling out with that, and we'll see where it goes. We'll eventually want to get to my idea on magic number, which is not original, but the magic number idea with Cisco subnetting will greatly help you with your CCNA goal. So here I've got an IP address 192.168.3.55 IP version 4 address, and oftentimes in the CCNA you'll see it spelled like this with like a /24, right? So 192.168.3.55. Well, right off the bat, what does that mean? Well, what the /24 is, it's a shorthand for the subnet mask or the net mask, which in this case would be 255.255.255.0, okay? And why is this 24? Why does that relate to this? Well, these right here are octets, okay? So each octet is 8 bits in length. So if we were to write out 255.255.255.0 in binary, it would look like this. And it would be, there's the first octet, there's the second octet, third octet, let's see here, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, 8, and it goes right off the page, so I'm going to make the font smaller so you can see it a little bit easier. Okay, so there it is. So, and it wouldn't of course be all ones at the end, it would be 0, 0, 0, 0, 0, 0, 0, 0. So sorry about that. So 255.255.255.0 in binary is 1, 1, 1, 1, 1, and then ones, and then ones, and then zeros. And if you were to count up all these ones, there are 24 ones. So there's where the /24 comes in. Okay, 24 ones and 8 zeros. So, and the way this works out is the process of the reason this is important to understand is that the process of finding the network is done by the router, and the router uses, when it does it, it uses a process called ANDing, which is essentially relates to logic, truth tables, and we'll talk about that right now. So what the router was going to do, if the router gets this IP address right here and this subnet mask, what it does is it logically ANDs, right? AND logically ANDs the IP address with the subnet mask to find the network. So in this case, I'm going to write out now the IP address. So 192 is this. All right, that's 192. 128-bit plus the 64-bit makes 192. Remember, this is place values, right? So for every 8 binary bits like this in a numeral, you've got the 128's place, 64's place, 32's place, 16's place, 8's place, 4's place, 2's place, and the 1's place. Or 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. Okay, so there's 192, right? This one is in the 128's place right here. This one is in the 64's place right here. If you add those two together, you get 192. So this is the number 192 written in binary. And then 168, well, this is how you do it. You say, do I need a 128? Yes, 128. Do I need a 64? No. Do I need a 32? Yes. 128 plus 32 is 160, right? So I don't need a 16-bit, but I do need an 8-bit. And now I have the number 168 in binary. 128 plus 32 is 160, plus 8 is 168. All right, now the number 3, that's pretty easy. 0, 0, 0, 0, right? And then 4, 2, 1, so 4. No, I don't need a 4, I need a 2 and a 1. Okay, there we go, that's the number 3. And then the number 55, that's going to be 0, 0, 1. And then 32 plus 16 is 48, so I need another 1, right? 48 plus 8 is 56, so that's not it. And so then I'll need the rest here. And that's 55. Let's count it up and see if I did that correctly. 32 plus 16 is 48. That's 52, 54, and 55. That's correct. So here we have the number 192.168.3.55. 55 in binary and the subnet mask down below in binary. And so now we're going to do a logical ANDing, and logical ANDing goes back to logic, and I'll see if I can bring the proper symbols up. Let's go to Wikipedia, and just really quickly, let's see here, go to Google. Okay. Logical AND, right? Logical conjunction, just look it up very quickly in Wikipedia and bring it up, and here it is. Here's the truth table in Wikipedia, the truth table of P and Q. So if P and Q, then this. So if P is true and Q is true, then you have a truth. If P is true and Q is false, you have a false. If P is false and Q is true, you have a false. And if P is false and Q is false, then you have a false, right? Well, with binary, with Boolean logic, George Boole changed the trues and falses basically, or proposed that we use the numbers. So instead of true and false, you would have applications in computer programming. So instead of true and false, you have if false and false, 0 and 0 equals 0. False and a false makes a false. A false and a 1 makes a false. A true and a false, a 1 stands for true. True and a false makes a false, and a true equals a true. So we apply that logic here, and what I'll do is underline this, and we go below to find the network. So all the computer does is logically ANDs these numbers together to find the network. So 1 and a 1, right? A true and a true makes a true, right? And I won't underline this. And then a true and a true makes a true, and then a false and a true makes a false, false and a true makes a false, and so on and so forth. Okay, and then you'll see here that on the next octet, a true and a true makes a true, and a false and a true and a false and a true, false, false, false. So that's 192, 168, and then we get to the next octet, and we've got the same logic happening here. Okay, and so far we find out that what we have in decimal form is 192.168.3, and now when we get to this last octet right here, notice these are all zeros, so everything, 0 and a 0 makes a 0, 0 and a 0 makes a 0, a true and a false makes a 0, so everything's going to be 0 here. And so we find out that the network is 192.168.3.0. Okay, that is the network that the router is going to route to, and so this is the process of how we take binary, why it's important to understand how binary works, because the routers in Cisco CCNA, essentially what happens is the router takes the IP address right here and ANDs it, logically ANDs it with the subnet mask or the net mask to find the network. And in this case, it's very easy. It's 192.168.3 network. Now, a lot of people just know this instinctively, and this is really great, and everything works out fine until somebody comes up with a subnet mask like this and turns this to 28. So now it's /28, and now it's a 255.255.255, and /28 would turn into a 240. So you have a funny subnet mask now with 255.255.255.240, and you've got to solve the same problem. And that's where it becomes difficult, and that's where the magic number comes in handy as well, which I'll talk about in the next tutorial.